There's been a lot of confusion around LCD TV backlighting recently. Today, I'm going to take you inside an LCD TV to explain how some of these new backlighting technologies work. I'm Tim, and this is Learn TV. LCD TVs haven't been a mainstream technology for very long, so it's no surprise that it's quite confusing trying to keep up with all the technologies in them. Today, I want to try and simplify some of that. All LCDs fundamentally work the same way. They have a backlight behind the screen, and that backlight is shining through a liquid crystal panel. Each individual pixel is represented by a liquid crystal door, if you like. That door can open to a variety of different levels to allow various amounts of light to pass through it. In front of each of those doors, you have a red, a green, or a blue coloured filter. On a panel like this one, which is a full HD panel, 1920 dots by 1080 dots, for each one of those 2 million pixels on screen, or each one of those 2 million dots on screen, you have a red, a green, and a blue coloured filter, and doors, LCD doors, behind them, which are allowing the light to pass through. By combining all those colours together, you get a complete full colour picture. But as you can imagine, in a system like that, there are a variety of elements that are going to determine the picture quality. Obviously, the backlight is one of them. The backlight can affect the brightness of the picture. It can affect the colour accuracy of the picture. Imagine if you've got a backlight that is a slight yellow tinge to it. If you then shine it through one of those red coloured filters, instead of getting a nice deep red, you're going to get a colour that's a bit more orangey. The panel itself determines things like viewing angles. You may have heard of response times as well on LCD TVs. That's a specification that we don't use a lot anymore when describing LCD TVs because it's not as relevant as it used to be. Most LCD TVs that you buy are quite capable of coping with full video motion without causing too much blur on screen now. The other element which is really important in an LCD TV is the picture processing. So if you're looking at two TVs side by side, chances are they will have similar panels, they'll have similar backlights, but the video processing itself, in Sony's case we describe it as Bravia engine, is actually going to affect the picture quality far more. Today I want to focus on backlights. This is a conventional fluorescent backlit LCD. So these tubes are what's called cold cathode fluorescent lights. You might see them occasionally described as CCFL backlights. This is a good way of backlighting an LCD TV because they're very low cost and they produce a good light output and last for a long period of time. However, there are some limitations of backlighting an LCD TV in this way. The first is colour accuracy. The intention with a backlight is to create as white an output from the light as possible. Now, the whiter the output, the broader the range of colours that you're going to be able to produce out. This is because white in light actually contains all of the colours. So if you shine a pure white light through a red coloured filter, you're going to get a purer red out of it. CCFL backlights are a little bit limited in terms of their colour range because they're not pure white. Sony have developed a special coating on the fluorescent tubes which produces a purer white light output, and many Sony TVs offer a wider colour gamut as a result of that. The other limitation with CCFL backlights is that they're not as power efficient as they could be. A CCFL backlight is still far more power efficient than other display technologies, but again, Sony has developed a technology called HCFL, or hot cathode fluorescent backlighting, in order to enhance the backlighting power consumption even further. The other type of backlighting, which you're likely to find on more expensive LCD panels, is LED backlighting. Now, LED backlighting shouldn't be confused with LED televisions or OLEDs, which you may have also come across. LED backlit LCD TVs, while some manufacturers do describe them as LED TVs, are in fact the same LCD TVs. The only difference is that instead of using the fluorescent tubes, they're using small light-emitting diodes, or LEDs, for the backlighting. There are three main ways that they use LEDs for backlighting LCD TVs. The first is conventional white LED backlighting. Now, this effectively has an array of white LEDs behind the screen which creates the light source. These are very good as far as low power consumption and relatively cost effective as well, although still a lot more expensive than fluorescent lights for backlighting. The second developed by Sony back in 2004, is RGB LED backlighting. Now, RGB LED backlighting offers far superior colour to any other display technology. RGB stands for red, green and blue, and this system actually uses red, green and blue LEDs combined to create a purer white light output than you could produce with a single white LED alone. The third, which is the one that's getting quite a lot of hype at the moment, is what's called Edge LED backlighting. Sony introduced the first Edge LED backlit TV back in 2008, our ZX series. Now, the ZX series has got the advantage of being extremely thin, in fact 9.9 millimeters. So this is the principal benefit of Edge LED backlighting. With Edge LED backlighting, you have an array of LEDs that run around the edge of the screen, and then a clever light diffusion panel which makes the light come from the edges and give you an even backlight behind the panel. The important thing to note is that while these TVs are using LEDs for backlighting, they are not LED TVs. Let me show you why. You've probably actually seen real LED displays before. Certainly if you've been to a large sports match, or you've been somewhere like Times Square where there are large video billboards, most of those are created using LEDs. The reason why you don't find LED TVs in your home is that LEDs are simply too big. Here's one to give you an idea. Now this is actually a fairly small one, but most of you will have seen LEDs before. They're used in all manner of devices. But in order to be able to compare this to the pixels on a full HD TV, I'm going to need to get the camera a little bit closer. Fortunately, I've got a microscope here that magnifies images by 30 times. So we can use this to have a closer look at the actual pixels on this LCD TV. You can just make out the pixels on the TV now. To put this in perspective though, here's that LED again. So there's simply no way that you would be able to create an LED TV in a conventional 40-inch or 46 or 50-inch screen size that we are used to. Now, while these are obviously not LED TVs as such, they do still have a number of benefits over conventional fluorescent tubes. LEDs are far more power efficient, which means that you can produce a brighter image than a fluorescent tube, and you can do it by using less power. So they're more economical to run. The other benefit of LEDs is that you can switch them on and off much more quickly. Now this means that you're able to do things like local dimming. Found on Sony's RGB LED backlit TVs, local dimming allows you to turn off just parts of the picture in order to enhance black levels and therefore contrast in the picture. The benefit of this is that unlike a lot of other technologies, you can actually enhance the contrast in a given image. That means that you can produce a nice deep black and a nice bright white on screen at the same time. This sort of thing is not possible with Edge LED backlighting. Edge LED backlighting, while you can switch the LEDs off, by doing so, you dim the entire screen. So it's great if you've got a completely black picture on screen, or if you want to produce a very bright image. You can also produce extremely high specifications for contrast. However, in practice, it's not going to give you a deep black and a nice bright colour on screen at the same time. Just to clear up any confusion about the difference between what some manufacturers describe as an LED TV, in other words an LED backlit LCD TV, and OLED. OLED uses self-illuminated pixels. Now this means that you can produce incredible black levels and contrast. The other benefits of OLED are excellent colour gamut, very good response times, and very wide viewing angles. Because they're self-illuminated, you don't need any type of backlight, which means OLED TVs can also be made incredibly thin. The only OLED TV that's currently available is the XEL1. It's a Sony product, an 11-inch TV, but it is 3mm thin. So it's incredibly thin, and the picture quality, from experience, is quite outstanding. The main thing is, don't get these confused with LED TVs. So LED TVs, as I said, is a marketing term that is used by some manufacturers to describe LCD TVs which use LED backlighting. Well, I hope that's enlightened you in some ways to how LCD TVs work. The backlighting is certainly very important in the overall picture quality of an LCD TV. It affects the power consumption, the brightness, and to a certain extent the colour accuracy on screen as well. However, it is not everything to do with picture quality. The picture processing and the panel also play a big part. So the important point is to always use your eyes rather than the spec sheets when you're comparing one TV to another. Thanks for watching. We'll see you next time on Learn TV.